Hi everyone, this video is going to take us through section 2.3, which is getting information from the graph. So given a graph of something, how we can gather information, making sure we understand the language that we're starting to get used to, our language of functions. And the first thing I want to ask though is this a function? Is this the graph of a function? So I'm going to be doing a little bit of reviewing of 2.2 to see if we can remember all of that kind of stuff as well. So 2.2, to tell if a graph is a function, it has to pass that vertical line test. So kind of run some vertical lines through this graph, and we will see that it does only cross that vertical line at least only once. So yes, this is the graph of a function. And I will put in here, we did that vertical line test to kind of review again. This is a piecewise function because we see that it is different pieces of things. It's not like one smooth curve. And so we could define this in pieces, and maybe for practice we will, just to kind of double check everything that we're learning. So we'll kind of do a little bit of both. So I can see that this is a bunch of different pieces, and I'm going to put those little qualifiers as to when we're at certain sections. So kind of label my axes here for us so we can kind of get some numbers on there for us. The first one's going to go from -4, not including the -4 because we have that open dot, up until we hit that -2. Notice I could put it here or on that next one. I'm going to put -2 until we hit 0. And one thing we talked about in one of the earlier sections is we do not want to overlap these. Since these two meet at the same point, it will not matter where the equal piece is, but you have to choose one and only one. So I'm just randomly choosing this one versus this one. There's no reason I chose one over the other. The same when we're at x equals 0. Since this is on both sections, this diagonal line and this flat line, it's not going to matter where that equal sign is with the 0. I'm just going to put both equals on this piece here. Again, randomly chose those two parts. And then we went from 0 until 2, and then 2 until we hit 4. I will put an equal sign here on 4. The 2, again, is that they're both the exact same value, so again, it does not matter which one I include, but I can only include the one. Reason is we want the reader, whoever reads this formula, to be able to know exactly where to go when they are calculating f of 2. So let's see. Doing this first piece, it is this flat horizontal line, which has the equation like y equals a value. So on that piece, our function is equal to the value of 1. This is a straight line, slope of 1, 2 over 1. That does have a y-intercept of 5, so 2x plus 5. This third piece, again, is a flat, straight line that is at the value of 5. So y equals mx plus b, again, where m is 0. This fourth part has a slope of down 1, 2, 3, and over 1. So our slope is -3, and it does go through the point 2, 5. It goes through a couple other ones, but I'm just going to steal the 2, 5. And now going into my y point slope form, y minus y1 equals my slope x minus x1. Distributing my 3, and then adding 5 to both sides. that gives me this equation right here. So this is a little bit of review from the previous section on how to come up with a formula for a piecewise function. Okay, we wouldn't need this, but we'll kind of use this to kind of review some stuff from before as well as include some new things. So, what can I get from this graph? Well, we can get our domain. The domain, again, is those inputs, those x values that we see, that we use, and all the x's that we are going from is from a -4, not including the -4, all the way up until I do hit 4, and including the 4. So using interval notation, it's the interval from -4 to 4. We can calculate our range. Our range, again, is the outputs, or those y values that we get. So I'm going to be, again, looking on the y-axis, finding out what y values take on values. And I see that my smallest y value is a -1. I do get that value out, and I get every y value from -1 up until 5. And I also get 5, so we will also include that 5. So our range is going to be from -1 to 5. Okay, I need my graphs, so I'm going to steal another piece of paper here. Okay, let's see. Do that. Let's say I want to know what f of -1 was. I can do this two separate ways. I can do this now that I have my equations. I can go into where I would need to go. Okay, and from -1, -1 is between -2 and 0, so I could put it in here. So that would give me a -2 plus 5, which is simply 3. Or, if I hadn't done this extra work ahead of time, I can still get the answer to this question, what is f of -1, by using the graph. F of, this is going to be my x value, so this is actually just asking myself the question, what is the y value, or the output, when x is -1. So we could go to the graph. Here's x equaling -1, and we want to find the graph at that point. And notice we get that our function value is 3. So again, we get that it is 3. This is also a way to kind of check to see if our formula looks right. Okay, let's do another one. Let's do f of, and let's go with 3. Okay, and I'm just going to use the graph. So this is asking me, what is the function when x is 3? So the function is like the y value. So what is the y value when x is 3? So here's x equaling 3, and my y value then is 2. Yes, we could have gone into our equation, which would have been this piece, because 3 is between 2 and 4. Substituting in the 3 there, I get -3 times 3, which is -9, plus 11 gives me that 2. All right, other questions? And again, I'm just going to use the graph. Which is larger? F of 4 or f of -3? Okay, so we want to calculate or evaluate or compare f of 4. So the function at 4, the function at 4 is down here, is at a -1. The function at -3 is a +1. So which is larger? That would be f of -3. Would be the larger value. Okay, let's ask another question. For what value or values of x is f of x equal to, let's see if I can find a good one. Let's go with 0. Okay, so we want to know for what values of the x is our function. So where is y, another name for f of x, is where is y equal to 0? In other words, where did it cross the x-axis? And that happened right about here. My graph is not very accurate because this does have a slope of 3, so this is not actually a half. So it would be x is equal to that 2/3. Since we had a slope of -3, when I went down 1, I'd go over 1/3. Down 1 more, I'd be over another 1/3, or at 2/3 is where I came up with that. So when they ask you where is f of x equal to something, they're asking where is that function, where are the y values equal to that value. For what values is f of x, let's say, greater than 0? Okay, what does that mean? Well, it's asking ourselves for what values, oops, I should have put of x, is f of x. Like another name for f of x is y. Where are our y values greater than 0? Greater than 0 means positive. So we're asking ourselves where is the y values positive? Y being positive is up here. So we are going to be above the x-axis. And that happened for all of these x values until I hit that 2/3. So if I write this in interval notation, it would be from -4, not including -4 because we have an open hole there, until we get to that 2/3. And the question now is, do we include that 2/3 or don't we include the 2/3? And the answer to that will be asked here. Do we include when it is equal to 0 or do we not include it? Since we are not including the 0, we have a round bracket. If I had put greater than or equal to 0, we would have had a square bracket. So it kind of depends. Do we want to know when it is equal to 0 or just greater than 0? Okay. We are going to put a couple of definitions in here, and these are from your book. I'm not going to actually write this one out, but I'm going to talk about it. How to tell if something is increasing or decreasing. The technical definitions are located in your textbook, so make sure you go and read those. They are kind of complicated, and I'll kind of talk through it when I do the local max and min idea, how you kind of read some of those. Increasing, a lot of us know what it means to increase. Increase means get bigger. So when we're looking at a graph and we're talking about increasing, first of all, we read a graph from left to right. And so when we're talking about increasing, we're going to be talking about something going up. So as our x's go from left to right, our y values get larger. So that means going up. So we see that this thing is increasing on this area here. Now when we are asked where a function is increasing, we want to know where the x values are. We don't care what the y values are doing, we know that they're going up. We want to know when does that happen. And it happens when x starts at -2 and it continues until 0. That's where we had this thing going up from x equaling -2 to 0. And when we're talking about increasing and decreasing, we don't increase or decrease at a specific point because right here, at this point, we're not really doing anything. We're just standing still. We only increase as we move. So we don't talk about increasing at a specific value. We talk about increasing over an interval. Same for decreasing. Decreasing means we are going to be going down. So this function goes down in this region, but again, we're going to be concentrating about the x values. So from here to here, you'll notice that our graph over that region is going down or decreasing. So we decrease from 2 until 4. At 2, we aren't really doing anything. At 4, we're not really doing anything. We're just kind of standing still. It's kind of like you climbing a hill. If you stopped, you aren't really going up or downhill. You're just on the hill. So at a point, you aren't really increasing or decreasing. You are increasing and decreasing over intervals. The last thing here that I want to talk about, and then I'll stop the video, is talking about maxes and mins. And I'm going to put this definition on here. The function value f of x. So we're talking about a y value. So f of x is another name for y, is a local maximum, and I'm going to put in parentheses underneath it, minimum, because they're very similar to each other. They're considered a maximum value of f if f of a is greater than or equal to f of x when x is near x equals a. And if you're talking about a minimum, we're going to be smaller. Okay. I know this looks like a lot of words and things like that. Again, we're learning how to read mathematical statements. In this class, we're going to learn a little bit more on how to read mathematically. So the function value, f of x. So this is just another way of saying the function value. So here's its name. So in other words, the y value is a local maximum if for every x value near this point, so f of a, this is going to be our f of a, oops, and I should make this an a, is going to be a maximum if that guy is bigger than everybody else around him. So this is like the biggest y value when we're close to it, or the smallest y value. So when I'm looking here, and I'm looking for maximum values, I'm looking for high points. So f of 0 would possibly be considered a maximum. I do have one for sure minimum. I do have a minimum value here at f of 4. So f of 4 is a minimum. I'm going to come back with another video with a different graph so we can talk a little bit more about maxes and mins. Local max, local min. I'll bring out the textbook and we'll look at this actual definition again. I'll also look at the definitions for increasing and decreasing and talk through them so we can learn a little bit more on how to read mathematically.